Okay, so let's look at this problem. So here's another piecewise defined function, and a and b, so just so you're aware, so this function depends on two unspecified constants, a and b. And the goal is I want you to find the values of a and b such that this function would be continuous at x equals -2. Or explain why such values don't exist. Okay? So this is a very typical example we like to give, right? We have some function that is dependent on some parameters like a and b, and now I want to find out how should I set those parameters to make the function continuous. I'm going to give you a few minutes to work on this. Now, if you're not sure where to start, right, start with the definition of continuity. The definition of continuity is what? Limit as x approaches c has to equal f of c. And I know that this thing on the left-hand side also kind of breaks down into two other things, right? The limit from the left has to equal the limit from the right. So the condition for continuity, again, we talked about this in the previous example, but just to reiterate, is that there are three separate numbers that all have to be equal to each other. So use that as a hint for getting started with this problem. I'm going to give you, say, 4 minutes and some change to work on this. Now, try to really like pretend this is an exam, right? Write out a full, proper, precise explanation, complete with proper notation, sentences, everything. Right. Look at this. All right, so like I just discussed, we want to set three quantities equal to each other. Now, the idea here is that because the function itself depends on these two unknown parameters, these quantities are going to depend on those unknown parameters as well. I mean, the idea is we're going to set my left limit, right limit, and function value equal to each other and solve for those parameters. Okay, so let's start. Okay, so first we calculate the left limit, right limit, and function value at x equals -2 in terms of a and b. Okay? So let's look at the left limit. Okay, so for the left limit, we have the following calculation. Limit as x approaches -2 from the left-hand side. Which piece do I actually have to use? So let's check that. So if x is approaching -2 from the left, that means I actually have to use this first piece, right? So I need to calculate the limit of x to the fourth minus 16 over x plus 2. Now, as usual, I directly substitute just to get an idea of what's happening. And direct substitution of x equals -2 gives us 0 over 0, right? The most difficult type of limit to deal with. So how do we proceed from here? I still saw a bunch of you on the exam, by the way, write things like, oh, 0 over 0, therefore the limit is undefined, or therefore the limit doesn't exist, or therefore the limit is 0. Remember, 0 over 0 does not mean limit does not exist. 0 over 0 tells you that there is some algebra that lets you cancel things out. So factor out the numerator. So would you like to tell us how to factor the numerator? Either Huvo or another student? So how do I factor the numerator? Good, it's a difference of squares. So x squared minus 4, x squared plus 4. And then what Hoover wrote down is then the factorization just for x squared minus 4, right? Because now x squared minus 4 is itself a difference of squares, so I can factor that out as x plus 2, x minus 2. And now finally I can say, okay, now cancel out the x plus 2 is good, right? Because x is not equal to -2, so I can cancel them out. And I'm left with this expression. And then I can now directly substitute -2. So if I do that, let's see, I get here -4 times 8. So I get -32 as my answer. Okay, so we're still not done, right? That's the left limit. Okay. Now let's look at the right limit. Let's look at limit as x goes to -2 now from the right. And which piece do I have to use for that? So let's again scroll back up. So which piece was that? So if I'm approaching -2 from the right, I need to use this third piece, bx plus 3. Okay. So how do I calculate this limit, and what is the value of the limit? How do I do this? So I'm not going to set Right now, I'm not setting anything equal to negative 32. I will eventually do that, but right now, I just want to calculate this limit, right? Because obviously, if I have to set this equal to negative 32, I need to know what this limit is. So one of the questions was, do you put the direct sub -2? So do you directly substitute -2? So let's ask that question to the whole class. Do I just directly substitute -2? Is there something else I have to do? Um, what do we directly substitute? Not sure. Well, let's see. A lot of people saying yes or yeah. So then, what is the value of this limit? So all those who are saying yes, you just directly substitute. What is the value of this limit? Okay, good. -2b plus 3, right? Keep in mind that b is just a constant. So this is just like any other degree 1 polynomial, right? It's like 2x plus 3 or 7x plus 3, right? It's just like any one of those functions. And how would you find the limit of one of those functions? You just put in x equals -2, direct substitution. It's just in this case, there is an unknown constant, but that's okay. It's supposed to have that unknown constant because eventually, like Joshua said, I want to set this equal to -32 anyway. So this is equal to -2b plus 3. So direct substitution of x equals -2, right? You're not putting in b equals -2. You're not trying to say, okay, bx plus 3 equals -32 and try to like solve for x in terms of b or something like that. No, you're calculating a right-handed limit. And so this tells you you need to substitute in x equals -2, right? That's what that limit symbol tells you. All right, now let's look at the function value. So what is f of -2? Scrolling back up to the function, f of -2 is just a. I have to use that middle piece. Now we're going to set everything equal to each other, right? So for f to be continuous, at x equals -2, right? I wrote this earlier before you started the problem. We need the left limit, the right limit, and the function value all to be equal to each other. Here it's -2. Right? All three of these numbers must be equal to each other. Now, sometimes I hear students saying, well, how can they be equal to each other? We don't know what A and B are. That's the point, right? The point is that we don't know A and B. And by setting these three numbers equal to each other, I'm allowed to then solve for A and B, right? A and B are unknown parameters. So let's see. So each of these we calculated. So the left limit ended up being -32. The right limit was -2b plus 3, and the function value was a. Okay. So now I solve for a and b, right? I have essentially you have two equations, right? You have one equation and a second equation. So I'll write as so one of the equations is -32 equals -2b plus 3, and the other equation is -32 equals a. Well, the second equation immediately tells you what a has to be, and the first equation immediately tells you that b has to be 35 over 2, or 17.5, right? Okay, so that's our answer then. So to make f continuous at x equals 2, or -2 rather, we must put a equals -32 and b equals 35 over 2, or 17.5. All right, good. Now, I just want to point out some common mistakes. And generally speaking, the common mistakes with these types of problems come from students not understanding continuity as a property of limits. Like I've said a few times in this class, everything in this class is about limits. Everything. If you're not using limits in some way, something's going wrong, right? When you're doing a derivative, that's limits. When you're doing an integral, that's limits. When you're doing continuity, that's limits. Everything in this class is limits. So a lot of times, so for this particular problem, sometimes they'll see students not use limits at all, and what they'll do is they'll think, okay, left limit equals right limit equals function value, and they'll think, okay, just set each of these pieces equal to each other. So I'll sometimes I have actually seen this, um, plugging in no numbers or plugging in numbers but with no limits. I see that. So I'll see some people write things like x to the fourth minus 16 over x plus 2, set that equal to a, and then set that equal to bx plus 3. And then they'll write over here, okay, so let's kind of cross multiply here. And then move everything over to one side, maybe. And then they want to solve for x. Right, I've seen this happen in exams. I've seen it happen in final exams, and like I said, it all stems from a misunderstanding, right? Not understanding continuity as limits, right? Because once you put on the correct limit symbol in each of these cases, this was the function value. I'll just leave that out. And once you put in the correct limit symbols, then everything becomes very clear, right? You're not solving for x. Nothing like that is happening.